Hi, my dears. Sorry this was not posted yesterday. The day kind of got away from me and I had a lot of stuff to do. So I will be doing this video and then I'm going to hopefully work on the next video and post it sooner. So just a reminder, I will not be here on Friday. Friday for you is a work day. You do have some homework that is uploaded into Delta Math. It's not due until next week, Wednesday. But remember, your CA is still due on Monday. So just keep working away. If you have any questions, let me know today. I rhyme. I don't even mean to. Okay, so we are on page 16, and we're going to be doing the rational zero theorem. So it's just theorem. Okay. But it's using, again, synthetic division, just like what we did last time, yesterday. Well, now today's Wednesday, but Monday, whatever the days are. So with this, there are going to be many types of zeros. You're going to have real zeros, which could be rational or irrational, or you could have imaginary zeros, which are those like a plus bi stuff. So those are complex zeros. So what we do here is that in order to find the number of possible rational zeros, we're going to use the theorem, possible rational zeros equals factors of the constant term. So the constant term is just the term without the x. Okay. Put those all on the top. And then the factors of the leading coefficient. So the leading coefficient is the number in front of the term with the highest degree. Okay. So watch and learn. These examples, we're going to list all possible rational zeros. So remember, these are just possible. So they're not actually the zeros, but they could be the zeros. Rational numbers just means that they can be put into a fraction form. So what I do here, so possible rational zero, PRZ, if you will. So we're going to take the factors of the constant term. So the constant term in this is the one without the a variable. So the constant is 4. The leading coefficient in this one, so I'll kind of highlight here. So 4 is the constant. And then the leading coefficient is that which is technically a negative 1. Okay, now in this case, I know it's negative, so basically we would have to have a negative and a positive. But just think of, for the constant term, okay, you could have 2 times 2 or negative 2 times negative 2 to give you 4. Okay, so with all of these factors that we put, we're going to be putting a plus or minus sign in front of them. Okay, so the factors of 4 are 1 with 4, and then 2 times 2. And like I said, all of these have a plus or minus sign in front of them. We divide it by the factors of negative 1. So it's just 1, positive, negative. Okay, that's it. So when you have this, what you want to do is you want to divide all the numerators by the denominator. In this case, since the denominator is 1, you just get possible rational zeros of 1, 2, and 4, and the positive or negative of them. Okay, that's it. Those are just the possible rational zeros. And this will help us with what's on the bottom, and you'll see in a hot minute. Okay. So let's look at number 2, possible rational zero. Well, let's see here. So we need the constant. That's a pretty color. Here's the constant. And then there's the leading coefficient. So the constant is -6, and the leading coefficient is 2. So what we do is we take the factors of our constant, which just think of it as regular 6. So it's 1 times 6, and then 2 times 3. Those are all the factors of 6. So factors are like what divides into that number. And again, we put our plus or minus sign with each of these. Boop, boop, boop. Okay, our leading coefficient is 2. So the factors of 2 are 1 and 2 with plus or minus signs. So from here, we already know that if we divided all these numbers by the 1, okay, we just get those same numbers again. Okay, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. But now we also have another factor on the bottom. Ooh, crudsicles. Let's see if I can get rid of that. There we go. Let's see if I can make this a little skinnier. Okay, there we go. So now we're dividing each of these numbers by 2 as well. So we get plus or minus 1 over 2. We also get plus or minus 2 over 2, but that's just 1, and we already have 1 right there. So we don't need to recopy that. Plus or minus 3 halves. Okay, we don't have that yet. And then plus or minus 6 over 2, that's just 3, and we already have that right there. So we don't need to copy that down again. Okay, so those are all of the possible rational zeros for that specific equation. Last but not least, h of x, PRZ, possible rational zeros. Okay, well, that's a pretty color. It's like lavender. I like lavender. I think I just like to say lavender. Okay, so the constant is -2. The leading coefficient is 15. Okay, so the factors of 2 are just 1 and 2, plus or minus sign. Factors of 15, 1 times 15 gives you 15. 2 times, you can't do 2. And then 3 times 5 gives you 15, and those are all of the factors. So put plus or minus, plus or minus, plus or minus, plus or minus. Okay, we've already seen that with the 1, it just gives us the originals. So we're just going to say plus or minus 1, plus or minus 2. But now we have a denominator of 3. So divide each of those by 3. You get 1/3 and 2/3. Do the same thing for 5. And you get plus or minus 1/5, plus or minus 2/5. And then last but not least, the denominator of 15. So plus or minus 1 over 15 and plus or minus 2 over 15. So that is a lot of possible rational zeros. So the bigger the coefficient, the leading coefficient is, or the constant term is, then the more possible rational zeros you can have. Okay, so this right here mixed with the factor theorem, okay, just as a reminder, when you divide synthetically by any of these, if they are a zero or a factor, then the remainder will be 0. So what we're going to do here, because this is if you can't use your calculator, is you're going to find the zeros, all the zeros of the following. So let's look at this first one. So what we're going to start with is we're going to start by trying to figure out what the possible rational zeros are. Okay, the possible ones. So we have our constant, and then we have our leading coefficient of 1. So constant is 6. Oh, -6, sorry. And leading coefficient is 1. So that makes things pretty easy because the possible rational zeros are just, let's see, 1 goes with 6, 2 goes with 3. They all have plus or minus. And then since the leading coefficient is 1, we need to have plus or minus 1 on the bottom because that's the factors of 1. So the possible rational zeros are just 1, 2, 3, or 6, and the positive or negative forms of them. So from here, pick any strategy that you want, okay? It really doesn't matter just as long as you start finding zeros. So what I'm going to do is I start with the smallest one. Sometimes I start with the biggest one. I don't know. It doesn't really matter. So I'm going to start with 1. And I'm going to synthetically divide this function by 1. So I write the coefficients 1, 2, -5, -6. Okay, there were no placeholders that I had to get because it just goes 3, 2, 1, 0. Okay, so now I'm just going to synthetically divide. So I get 1. Do your backwards check mark, and you get 1. 2 plus 1 is 3. Do it again. Backwards check mark. You get 3. Bring it on down. You get -2. And then you multiply 1 by -2. You get -2. And you are left with a remainder of -8. So, wah. That's not going to work. So, we know that positive 1 definitely does not work. Let's try -1. Okay, same coefficients. Okay, so sometimes you need a good amount of space for this, but hopefully what I have works. So multiply, put that there. I get -1. Combine, you get 1. Multiply, you get -1. Combine, you get -6. Then multiply the last one, -1 times -6, you get 6, and you get a remainder of 0. Look at the little donut hole there. Okay, yay! Yay. So what that means is that one of the zeros is definitely -1. Okay, we found 1 0, yay! Okay, so from here, all we have to do is turn what we have left over down here into the, like a polynomial. So we get, we start with an x cubed, so we have 1x squared plus 1x minus 6, and set that equal to 0. We can find zeros of a quadratic extremely easy if we know how to factor, which we want it to add to 1 and multiply to -6, which is 3 and -2. If you t-chart those, you get x equals 3 and x equals -3 and x equals +2. And that gives you all your zeros, my dears. Okay, since it's a cubic, which has a degree of 3, you should have 3 zeros, and that would do it for you.